Let's do problem 31 on page 297. I'll read the problem. A 250 kilogram cast iron car engine contains water as a coolant. Suppose the engine's temperature is 35 degrees Celsius when it is shut off. The air temperature is 10 degrees Celsius. The heat given off by the engine and the water in it as they cool to air temperature is 4.4 times 10 to the 6 joules. What mass of water is used to cool the engine? Now this one is different than most of the problems that we've done. This is not really an equilibrium temperature. Yes?
Isn't this specifically of water 4,180?
Oh, is it 108? Okay, thank you. Yeah. So I looked this up. No, it's 180. Well, anyway, so here's my drawing of the engine. I just drew kind of a blob. Here's your engine, and it's got water inside of it and all that. But here's what it's doing. It's losing heat to the environment. Heat is flowing out of it. Its temperature is going down. Now, when a system loses heat, it says it lost 4.4 times 10 to the 6 joules. I put a negative in front of it. Almost, I don't think anybody did that when I grade your homework quiz. So, a negative there. Now, you don't have to do it that way, but let me show you, okay, how it works. Now, the final temperature of the engine is 10 degrees Celsius. It just cools down to the environmental temperature. It starts off at 35 degrees, both the water and the iron in the engine did. And then for iron, we had 250 kilograms of iron. We don't know the mass of the water, but we know the specific heat of the water, and I looked up the specific heat of iron. And we want to know, what is the mass of the water? Okay, so let's solve this here. Well, here is the physics of it, and it's simple. The heat lost by my system is equal to the heat lost by the water, or by the iron, I'll use I for iron, plus the heat lost by the water. Right? They're both going to lose heat. They're both going to cool down. The water and the iron in the engine are going to cool down, and when they cool down, they lose heat. And when I add up the total amount of heat that they lose, I get the total heat lost by the system. Does that make sense to everybody? Okay, so this is really not well, it is reaching equilibrium with the environment, but the environment's not going to warm up. The environment is so big, it's so vast that its temperature doesn't change. So anyway, now this is given to be 4.4 times 10 to the 6. Well, but before I do that, I'm going to keep it as a variable and break this down a little bit. So this is the total heat lost by the system is equal to the heat lost by the iron. That's going to be MC delta T for the iron plus MC delta T for the water. Now this is good because here's the variable I want. I want the mass of the water. So all I have to do is take this expression and solve it for the mass of the water and then plug in my values and I will get the answer. So let's go ahead and do that. So right now, this is where all the physics is at. After this, it's just algebra 1. So let's solve for the mass of the water. And I'm just going to do it in one step. The mass of the water is equal to the heat lost by my system. Then I'm going to subtract this to the other side, minus MC delta T for the iron, divided by C of the water times delta T of the water. Now we need to be now I'm going to plug in values, and this is where we have to be really careful. What is the heat lost by the system? It's 4.4 times 10 to the 6 joules. but it's the heat lost by the system. It lost it, so you should put a negative in front of there. And then minus the mass of the iron, which was 250 kilograms, times the specific heat of iron, which is 450 joules per kilogram degree Celsius. Now, what is the change in temperature? It's the final temperature minus the initial temperature. Well, what's the final temperature of the iron? The final temperature is 10 degrees. What's the initial temperature? 35. What is 10 minus 35? Negative 25 degrees Celsius. And this is where people sometimes went wrong, is keeping track of these negatives. Now, the specific heat of water is 4,180 joules per kilogram degrees Celsius. And what is the temperature change of the water? It's negative 25 degrees Celsius, right? The water was, the final temperature of the water is 10 degrees. The initial temperature was 35 degrees. So final minus initial is 10 minus 35 is negative 25 degrees Celsius. Now I've got a negative in every term. Here. So I'm going to cancel it out. Just like multiplying top and bottom by -1. Now, those of you who got 5 out of 5 on this, and there were a few of you who did, almost all of you did this. You called this positive, and you called your delta T 25 instead of -25. And you got the right answer. So I'm going to say, okay, and you basically knew what you were doing. You showed your work. But I want you to see that when a system loses heat to the environment, we say that Q is negative because it lost energy. When a system loses energy, we say that that's a negative change in energy. Right? When we were dealing with friction, and friction was taking mechanical energy away, we said the work done by friction was negative work. Same thing is true when a system loses heat. Now, when you take all this and you plug it into a calculator, the mass of the water turned out to be 15.2 kilograms. Okay? But this is what I really wanted to see. This is where the physics is. The total heat lost by the system is equal to the heat lost by the iron plus the heat lost by the water. Now, we can figure out the heat lost by the iron. It's just MC delta T for the iron. So if you subtract these two, that's the heat lost by the water, and then you can just solve for the mass of the water. Okay? Any questions on this problem? Let me try to get it all fitting on the screen. Okay, that is all.